Now let's look at a couple more factoring and then solving problems from 9.7. Let's say we had 4y squared minus 64. Now, you do recognize that both of those are perfect squares, but also you need to look at taking the GCF out so that it would be factored completely. If I factor out a 4, I'm left with y squared minus 16. Then this is a perfect square. 4 times y plus 4 and y minus 4. That would be the way it would factor. That should be the final answer. Now, some people would say 4y squared minus 64. Well, this is 2y and 8. So they would say it's 2y plus 8 and 2y minus 8. Notice each one of these. In each one, I could factor out a 2. So if I factor out a 2, I'm left with 2 times y plus 4. This one, I factor out a 2, I'm left with y minus 4. Well, 2 times 2, remember this is all multiplied together. 2 times 2 is 4. That's gone. Then I have a y plus 4 and a y minus 4. That is the final answer factored completely. A second problem, negative 9r squared plus 4s squared. If you notice, both of those are they are squares. I'm going to zoom in just a little bit here. But it's not written as a minus. Well, let's switch the terms. Let's say 4s squared minus 9r squared. Now it's written as the difference of squares. This is 2s, that's the square root. This is 3r, so it becomes 2s plus 3r, 2s minus 3r. And that's the way it factors. There's no common factors here. So that should be factored completely. Let's look at 9t squared minus 12t plus 4. Now, from a previous lesson, I could multiply 9 and 4, get 36, and set up my factors. But this is a perfect square, and that's a perfect square. So that should give me a hint to look at seeing if this will factor as a square of a binomial. This is 3t, the square root. This is 2. When you multiply that, you get 6t. Twice the product is 12. So this is 3t minus 2 squared. Minus because the middle term is minus. When you check it by FOIL, by the way, that's your final answer. But that means 3t minus 2, 3t minus 2. Going to check that. 9t squared minus 6t minus 6t. That's minus 12t. The last is plus 4. So it does check out. Let's look at solving problems. Let's solve 4w squared minus 49 equals 0. It typically means that we are going to solve by factoring. This is a perfect square. This is a perfect square, and it's the difference. So this factors into 2w plus 7 and 2w minus 7 equals 0. It's the difference of squares. Now remember, you factor. Now we are going to set each factor equal to 0. 2w plus 7 equals 0, or 2w minus 7 equals 0. Then we are going to solve. We subtract 7, get 2w equals negative 7. Divide by 2, we get w equals negative 3.5, or 3.5. Add 7 to both sides, we get 2w equals 7. Divide by 2, we get w equals 3.5, 3.5. Remember, if it's an exact decimal, you can write it in decimal form. Solve means to tell me what the variable is equal to. So don't confuse the term factor with the term solve. Second problem, let's take 4x squared plus 20x equals 25. Now remember, the first thing for solving when there's a degree 2 is to make sure it's set equal to 0. So we need to subtract the 0, 4x squared plus 20x minus 25 equals 0. We're subtracting 25 from each side. You'll get where you can do that part in your head. You don't actually have to write that. Now, this appears that this is a perfect square. This is a perfect square. I think I wrote this wrong. Sorry, this should be a negative 25, so we're adding because that needs to be a plus. I translated this from another problem. So this is the problem that I actually want. So we're adding 25 and we get this. This is a perfect square 2x. This is a perfect square 5. If you notice in the middle, that is twice their product. 10x, if you double it, it's 20x. So this will factor into 2x plus 5 squared equals 0. Now that means 2x plus 5 times 2x plus 5 equals 0. So you're going to set it equal to 0, you're going to factor, and then you're going to solve. These two factors are the same, so you only have to do it once. 2x plus 5 equals 0. Set the factors equal to 0. Subtract 5. You get 2x equals negative 5. Divide by 2. You get x equals negative 2.5 is the final answer. Sorry, that was at the bottom. This is called a double root. Both answers are the same.